So welcome everyone. In this video, we are going to be proceeding with a few questions of linked list, which will help you clear the concept of linked list. And the basic prerequisite for this video is the previous video of this series, in which I discussed how linked list actually works and what is the internal implementation. How do we make links and create nodes and every basic thing. And in this video, we are going to be seeing the implementation part. We are going to be seeing how a linked list is created using Python code, and along with it, we'll be seeing some of the very basic operations and quite important questions of that. And after that, I do have one homework question for you that you must attempt. So let's begin with the video. Well, if you remember the last video, we discussed the creation of linked list, but that was through diagrams and conceptual way. Here, I'm going to show you how the code for the same is written. So this code refers to the same. Let's try to read it. Okay, so when I talk about this, that means making the node. Whenever I execute this class, that means whenever I make an object of this class in Python, how is it done? I can simply say, let's say a variable name, and I can say the name of the class. Here it is node, and as you can see in the constructor, it is requiring data. So while making the object, I have to give a data as a parameter. So I will say, let's say I said node 10. So what will happen when this line executes? A node will be created. Whenever this line executes, a node will be created, and A will be referring to this node. And what this node will be containing is these values. So the first parameter is data. So in this data field, whatsoever we have sent here in the constructor will be stored because of this line, and because of this line, self.next equal none. The next parameter, which is called next, is going to be none initially. Okay, this happens whenever this line executes, a node is created. Now we have to create not just one node, but we have to create a whole list, right? So we have already seen how the connection between the nodes are made, right? If you have two nodes, let's say this one is A, this one is B, and both the nodes have the similar values. Okay, they have the data fields and they have the next fields. Initially, they both might be none. And if we have to connect these, how would I do that? I can only do it if I give B's reference to A's next. That means if I say A.next equal B, that means I am storing the information that where B is stored in the A's next. Thus, A would know that where B is kept, right? Thus, making this connection. So this is how we are connecting these nodes, but we have to compose a whole list. That means we have to come up with a new logic for it. Let's see how will we do it. So here I have made another class. The main functionality of it is actually holding the head. That means it is going to be referring to the head of any of the linked list that we are going to make. So this is our linked list class. We are going to make it. We are going to making its objects. Every object would be a separate linked list, and the head initially would be none. It will be having several functions. Well, to begin with, I have this add node function. What is the motive of this add node function? Well, basically, when we are talking about add node, the functionality that add node has is whenever you have a linked list, it will add one node to the end of the linked list. This is the functionality of add node. Okay, this is your basic linked list structure, and assume this is your new node. What add node function will do? It will add that node at the end of the linked list. Fine. Now I'm going to use this add node function to compose my whole linked list. Let's say I've created this function create linked list, and what I'm doing here is I'm taking one input from the user. That means how many nodes initially would you want for your linked list. Okay, and then I'm creating this object of this class. Fine. Similar in this fashion, correct? Similarly in this fashion, I'm going to create an object of linked list class. Then I am running this loop for n times, and for n times, I'm just calling this add node function so that my nodes are being created. Let's take a look at the add node function now. Well, initially what we are doing, we are creating up the new node. So no matter if our linked list is there or not, because that is also a case when the linked list is not formed, The very first thing that we'll do is we'll create a node. A node is created, the name is new node, right? And whatsoever data we are passing from this create linked list function, we are going to store that in this node. Let's say initially I'm storing 50, okay? And the next would be having none by default, right? Whenever this value is being called. Now, once I have my node, what will I do? I will check that if my head is there or not. That means there could be two conditions. If one linked list is already present, that means head would be referring to a node. Or if the linked list is not present, that means there is not even a single node in the list, the head would actually be pointing to none. Okay, this is the case. And I am interchangeably using none or null. Make it clear. Conceptually, null is generally used in the terminology of linked list, but Python is specifically call the same thing as none. Okay. Now that we know what has happened here, a node is created, right, like this. And currently, for the first iteration, my head is actually pointing to none. What will I do? I will say self.head equals new node. That means because this node that I've created is going to be the first node of my linked list, what will I do? I will attach head to it. And successfully, after executing these lines, our linked list of one node is created. Now, this was just the first iteration of a for loop. It is going to go on for n times, right? N minus 1 times more. Then for every time we are going to call this function, what will happen? This time, head is already present. Now this else part will be executing, right? What will I do? I am just attaching one more pointer to this head, okay? So I'm just, using one temporary pointer, you can name it anything. And instead of saying point, I must say reference in context of Python. So if I am using any reference, first of all, I have to attach it to head because I cannot move my head. Okay, I have emphasized that a lot in the previous video as well, because head is the existence of our linked list and we should not tamper with it. We should not move it. We can attach some different references to it and we can move those, but not the head. Okay, so right now what I'm doing here is I'm attaching my current to this self.head, that means this first node. And what I'm doing is I'm checking that while my current.next can travel, that means, well, the purpose of this code is actually to make your current reference to go till the end of the list. So you might not understand here. Let me attach a few more nodes. So assuming this is a node, this is a node, right? And just a second. And this is your new node. Fine, that is created in this iteration and the value is 70. Now what do I have to do? This is none. Current will move. Current will check. What is it checking? It's checking while current.next. That means until it is existing. That means, do I have current.next? Yes, I have one node next to the current. So what will I do? I will move my current. I'll say current equals current.next. So whatsoever value is the current of next, I will store that in current. This statement actually is used to move pointer to the next node. This will happen. Again, while loop is there, same thing I'll check. Do I have another node in front? Do I have another point to go to? Yes, I do. I will move my current to there. Okay. Eventually, my current would be here and the while loop would exit. Why? Because I do not have any node to go further. Okay. At this point, what do I have to do? At this point, what can I do? See, now you have this new node and you have your current at the last node. You have to make one connection, as simple as that. How would you do that? You can say current.next equals new node, right? So you must just write current.next equals this new node. And what will happen? This connection will be made, and because by default every next value has none, you don't have to take care of that. A node successfully would be added to your existing linked list. This is how this create function and add node function are working to create your linked list, right? I hope you have understood it. Let's move on to the second point, which is displaying or traversing a linked list. So assume I've taken this linked list. What do I have to do? I simply have to display that, right? For that, I have to go to each and every node. That means I have to perform a basic traversal. We have already seen that. I will still, tell you once more. What do we have to do? First, the very first step, attach a temporary reference. Name it temp or name it current or whatsoever you want. Name it here and attach it to the head. And if I am making this arrow, this actually means I am referring to the node. Okay, I'm referring to the node. So for doing this, what do I have to do? I simply have to say temp equals head. That means whatsoever value my head is pointing to, my temp would be pointing to the same thing. Okay, once this is done, now I would move my temp from the first node to the last node. How will I do that? I will simply, first of all, let's say what do I have to do? I have to print it. So let's say I'm printing it. Okay, you would figure it out yourself. Firstly, I have to print the first value. What will I say? I will say temp dot data, and I have to print that. Correct? After that, what do I have to do? I have to move my temp to the next node. What line do I write for that? I say temp equals temp dot next. Fine. That means my temp will then be moving to the next node. My temp would be pointing to 4 after execution of this line. Now what do I have to do? I have to print 10. I have to print 4. So I will say print temp dot data. This line would print 4. So if I just simultaneously write my output here, initially I'd be having 5 printed, and then 4 will be printed, right? After that, again, I have to move my temp to the next node. What will I do? I will again say temp equals temp dot next. This line will make my temp to move to the next value, right? Here, again, I have to print that. I'll say print temp dot data, right? This will print 18. Now you have started seeing repetition here, right? What we are doing? We are printing something and we are moving the temp, right? We are printing something and we are moving the temp. This is what we are doing continuously. So we can enclose these two repetitive lines inside a loop, and we'll be using a while loop for the same. Okay. So I can say, if I have to write, I can write something like while my temp can move. That means my temp is not coming till the end. That means till the last node. What can I say here? I can say temp is not equal to none. Okay, this could be first condition. That means I'm saying temp will go here, go here, go here, in this one, at this one as well. And after temp moves from this node, it will go to null, right? Because in 2's next is actually is pointing to null, or in Python you can say none. So what is happening here? You are jumping till none. So once that situation is encountered, you break out of the loop. So until your temp is not equal to null, you will keep on moving, and you would keep on doing these two things. You would print and you would move. This is what you have to do. You have to print, you have to move, and using this while loop. One more condition could be there, and in that condition you can actually, let's say you do not want to move till the none. You want to stop at the last node. Okay, you want to stop at the last node. Then for that condition, the while condition, this checking condition would change a little, and you can say while my temp dot next is not equal to none. Okay, now what change has been done? I will stop at the last node only, because I'm not checking the temp's value. I'm checking the temp's next value. So the moment I get to know that my temp's next is actually none, I will stop there. Okay, and I would not move my temp one more step so that it goes till here. Okay, these two are the conditions which we usually use to travel the whole linked list. Okay, now I hope you have understood how we are going to display or simply traverse a linked list. Moving ahead, this is the code for the same. You can see it. First of all, I am attaching one reference to my head. Then I am traversing using while loop, and I have written while current here. That simply means while current has some value. The moment current becomes none, I'm going to get out of the loop. What am I doing here? I'm printing, I'm moving, right? And I've used this arrow so that it looks a little fancier when it is getting printed on the screen. So taking the example of this linked list only, which we have here, this will be printed in this fashion. 5 will be printed. Then this arrow that is being displayed here will be printed like this on the output screen. Then the 4, then the value of 4, 18, 10 and 2. Once it is printed till here, 2 would be having one arrow at the end, and we are printing none at the last. So it would look something like this. Okay, so I hope now you successfully understood how a linked list is being displayed or being traveled. Now coming ahead to the next point, to the next question, or the very basic next operation that we have of linked list is actually inserting a node at any place. Now when I'm picking up this question, inserting a node at nth position, what do I mean? There actually could be three possibilities. The first one, we have to attach a node at the head. That means we have to make we have to set the first node of the linked list. Okay, we have to insert the node at the first place, or we have to insert the node at the last place, or we have to insert a node at any place in between. Okay, these three situations could be there, broadly defining. Let's cater that one by one. So what happens once I have to insert my node at the head, that means at the first position? What will I do? First of all, I have to create a new node, right? So for that, I'll simply say, let's say new node equals, I made this node, and let me say I gave the value 1 here. Okay, so once this line executes, what will happen? One box will be created, 1 will be given at the data field, and next would be having none. This is done till here, and its name is new node. Fine. Now what do I have to do? I have to attach it to my head, because only then it is going to be the first node, right? So for that, what I can do here, you can simply see it in the diagram. It is totally visible. What do I have to do? I have to create this link. How will this link be created? I have to say nn.next, that means new node.next, new node.next. What value do I have to give to this this field? What value do I have to give? Head. So I'll say head. Once I do this, this connection will be established. But still, notice one thing, one point is there. Now your head is actually pointing to the second node, which is not the definition of head. Head should always be pointing to the first node of the linked list. Now what should I do in that case? I have to move my head to the first node. Simply for doing that, we cannot travel in reverse, but we have the reference to this node. I can directly attach my head to the new node. So I can say head equals new node. Let me write it completely, new node. So what will happen? From here, my head will go to this first node, and it will be removed from here. And now the first node would be having, for this condition, it will be having the new node name itself until it is replaced, and the head would be here only. Okay. So as you can see, I have successfully attached one node at the head of my linked list, or as the first node of my linked list. This thing is done. Now, what is the second case? What can be the second case? Let's talk about when I have to attach a node to the end of the list. What will I do? For attaching any node, let's say I've created one new node. This is always going to be there. Let me again write the line, new node equals node, and again let me say 1. This is created. Now it is completely visible to you, and it is visual that I have to create this link to connect this node, correct? And to create this link, I must be having the control of this node. Can I refer this node? Can I say something.data equals to or something.next so that I can establish this connection? No, right? I do not have any reference to 2 yet. So for getting a reference to 2, what do I have to do? Again, the same thing that we have seen there previously in the previous one for traversing. I'll attach one temporary pointer here or current, whatsoever you want to name it. You have to move it from here, here, here till the end. So once I'm here, that means at the end of the node, I have to break out of the loop, break out of the traversal loop, and my temp should be pointing at the last node. Once that is done, what do I have to do? I have to make this connection. How will I do that? The name of this node is new node. I'll simply say temp.next equals new node. Once I do that, this node's connection will be established, and you already know the next field is none. So now you can see we have successfully, it is not none anymore. So now you can say it is successfully attached, and we have done the second case as well, in which we had to attach the node at the end of the list. Now comes the third condition, when the user would be asking you to attach at any nth position, right? Attach a node at any nth position. So let's say I want, in this case, I want my node to be attached at third position, right? Let's say I have to attach it here, in between these two, so that it will be 1, 2, and 3. That means first, second, third. Here, I have to attach this node. What do I have to do? Okay. Think it thoroughly. What can I do if I have to attach this node here? This is the node. 1 is the data field, and it is having none initially. What can I do so that my node is attached? 2 connections should be made. First of all, one connection in which this node, the new node, is pointing to this node, and the other connection should be this one, so that we can break this connection and we can make this connection. Once we do that, this node will be fixed in between 4 and 10, and the work will be done, right? The one thing that you must notice, what sequence have I followed of making the connections? I did not do, I cannot say that I'll make this connection first and then I'll make this connection. Why? Because the moment you make this connection, from 4 to new node, you lose this connection. And once you lose this connection and you do not have any reference to this node having the value 10, you would lose the linked list whatsoever is there, right? So to avoid that, what do I have to do? To avoid that, we must establish the connection from the new node to the node having the value 10 here. And then once this node is connected, I can now make this connection so that my connection is not broken. Connection to this further linked list is not broken. How will I do this? I'll simply, okay. So for making these connections, at least I must have a reference to this node. That means if I'm attaching at the third position, I must have one reference on the second position. Or simply, if I have to say, if I have to attach a node at nth position, I must have the control of n minus 1th node. Okay, how can I do that? I'll again start any pointer from here. Let's say I started current. I will move my current till here. I'll move my current till n minus 1th node, and from there I can make the connections, right? Let's see how can I do that. Assuming I have my connection here, what I'll do, first of all, I have to make the connection with new node and the node having 10. How can I do that? No reference is pointing to 10, right? Still, I have my current here at 4, and 4's next is this 10. I'll utilize that. I'll say new node dot next equals current dot next. What this line will do is, this line will establish this connection. So whatsoever value is stored here, the same value will be stored here. This connection will be made. Now I can successfully break this connection and make this one. That can be done in just one line. I can say new node, current node, current dot next equals this new node, right? Once this is done, what will happen? This node will be having the successful connection, and this node will be inserted in the given position, right? So I hope this was clear to you. Let's see the code for this. What is happening here? It is inserting at the nth position. It is taking up data, whatsoever new data you want in your in your new node, and then the position where you want to put your node in. First of all, we have created the node just like we have been doing. Then this is a separate case that we have dealt. That means we have to attach it at the head as a first node. So when position equals 1, I'll simply perform this, which we have already seen, right? What will I do? I will take my new node, assuming this is my linked list already created. Okay, this is my head here, and this is my new node. What will I do? I'll make this connection and I'll transfer my head from here to here. These two steps are done here. My new node's connection is made with head, and then my head is moved from there to the first node, from the second node to the first node, right? Once this condition is done, then both of the other two conditions, that means attaching at the last or attaching at any nth position, would be taken care of with this else code. What am I doing here? I'm just taking up my current. I am traveling my whole linked list till the n-1 position, or we can say till my current is placed till on my n-1 node, n-1th node. So how will that happen? I have to basically execute this line, current equal current dot next position minus 2 time. So if I have to go on third number, or let's take a bigger number. If I have to attach node at the nth position, I have to place my current on the 8th node, and to placing my current on the 8th node, I want this line, current equals current dot next, to be executed for 7 times. That means n-2, that is position minus 2. Okay, every time we are checking that my current is not becoming none, because if that is the case, that means my linked list has already ended. Or assume I only have my linked list till 5 nodes, and the user is asking me to attach one node at the 100th position. So how will that be? You cannot go beyond 5. The maximum you can attach it to 6. That will be the end of the node. So for checking that, I will keep on checking that my current is not becoming none. Once it becomes none, I'll simply print that it is an invalid position. I cannot print it here, and I'll return from here. If that is not the case and my current is being placed successfully at the position I need it to, what will I do? I will make the connection, and I will make the 2 connections that are needed, and the node will be inserted. So assuming this is A, this is B, and I have to insert it in between. I have to insert this node B in between these two. What will I do? This connection first. How will I do that? B's dot next equal A dot next, right? And I have to make this connection while breaking this one. This simply is A dot next equals B. And this is completely analogous to this. New node dot next equals current dot next equal new node. Done. Quite simple. I hope you have understood it well. Then now let's go further ahead for deleting the nth node. Now coming on to deleting the nth node. Again, for this simple thing as well, there could be 3 possibilities. What? The first one, deleting the first node, deleting the last node, or deleting any node in between, right? Again, let's cater it one by one. So when I say I have to delete the first node, that means I have to delete this node which is attached to head, correct? Now here comes a little tricky thing. There are 2 types of languages. One which can manage their memory, which have garbage collection, Python included, and some of the languages which do not manage the memory on your own, and those basically require the user to free the memory whenever needed. So we are going to see both the scenarios. Talking about the first one, that we have to delete the first node. What do I have to do? That means deleting the first node, or what it like typically as per the diagram means that my head now should be pointing to the second node, right? After doing this, I would assume that this node has become my first node and the linked list what I have is further on from here. If I cannot access this node, that means this node is deleted. Simply, if I cannot access any node in my terms, it is deleted. What can I do here is I simply can move my head. So what will I do? I will say that my head equals head dot next. Once I do this, the head would move one step and I would lose the connection to 5. There would be no way I can access this 5. That means it is deleted. For first type of languages which can manage the memory, it is great. Once the access to this memory is taken and I cannot access this memory, later on after a few executions, this memory will be freed by itself. But for the languages which do not free the memory until you ask them so, we have a few lines to write as well. What do I have to do? If I have to free this block or free any node in general, the bare minimum need is that I should at least be having one connection to that node so that I can ask my I can basically get the command that delete temp. So what happens with this line is that this node is actually deleted from the memory. Okay, now I have executed my head. I've moved my head. How can I place this temp? Because I have to place this temp, what will I do is before the step that I'm moving head, I will attach one temp to it. So this is my head. First of all, I'll attach one temp to it so that I do not lose the track of this node. I will say temp equals head. Right? Once this is done, then I would move my head. So my head from here goes to this node, and I still have this temp attached to 5. Now I can simply say delete temp, and this 5 will be deleted completely from the memory, and this is the list you have after the deletion of the first node. Now let's talk about the second condition. The first node is successfully deleted. Talking about the next condition. Now let's talk about the condition when we have to delete the last node. For doing that, what must be done? If I have to delete this node, what must be done? I simply have to break this connection and I have to point it to none. Once that will be done, the connection to this node will be broken and the linked list will be till here, right? This is how deletion of the last node works. For that, what do I need? For doing this, what do I need? I need one reference which can be present here. I need one temporary reference which can be present till here. What will I do? How can I do that? Again, the basic traversal. I'll begin from here. I'll keep on traversing till here. That means in the case we are deleting the last node, I have to come from the first node till the second last node. How can I check that? How can I check that? Simply I have to say, I have to put the condition while my temp dot next is not equal to none. That means I am checking this condition for 2 points further ahead. Okay, so for that, and simply you can add one more thing here, that my temp dot next is not none. Let me write it clearly. Give me a second. What I can say is, I can say while my temp dot next is not equal to none, and my temp dot next is not equal to none. By this line, what am I checking? I'm checking that I have one node next to me and I also have one node from next to me. Okay, so what happens, this line will help us to attach my node to the second last one. So that what will happen, my temp will begin from here, it will keep on moving till this point. At this point, this condition would be true. Temp.next equal none, that means I do have a node ahead it, but this condition will fail, that I do not have two nodes ahead me. At this point, I will break out of my loop and I will do the functioning. What is the functioning that I want? Just playing with the links. So this line, this loop is for traversing. So this is basically for doing temp equal temp dot next. After executing this successfully, my temp would be resting on the second last node. Now I have to break this connection. That's all. I have to break this connection. I can simply say temp.next equal none. My work will be done. Still, I have to, if I have to release the memory as well, what will I do? I'll say, let's say, I'd say current equals temp.next. That means I'm attaching my current with it. So my current is now attached to 2. Now I can break the link with temp. So what can I say? I can say temp.next equals none, link broken, work done. Where I have to release the memory, I can release the memory using del keyword del current. Done. Memory released. I have successfully deleted the last node. Okay. Okay, now so coming on to the third condition, that means I have to delete any of the node which is marked as nth by the user. So if the user is asking me to delete the fourth node, okay, let's talk about the fourth node. The user is asking me to delete the fourth node, this one. Okay, so for doing the same, what do I have to do? If I have to delete the fourth, I have to make this connection. That means from 18, I can directly go to 2. I don't want this node to come in between. For deleting this one, I have to make this connection. And for making this connection, I must have the hold of this node. Okay, let's say temp. I must have the hold of this node. Let me put it clearly. If I want to delete the fourth node, I must have one reference to the third node so that I can make the connection with the third, from the third to the fifth node. Okay, what we are doing here, we are just shifting the links, nothing else. It might seem a little complicated to you, but believe me, it is really simple. What do I have to do? I simply have to say, let's say I've kept my temp here. I've started from here and my temp has moved till my n-1th node when I have to delete the nth one. Okay, now I have to make this connection. This connection can simply be made by using temp.next equals, I have to fill some value here. What value do I need to fill in? I need to fill temp.next. Right now I have not broken any connection. That means all the connections are intact. So if I say temp.next, that means 10. This node having 10. And when I say one more dot next, that means this 10's next, which will be this 2. So this eventually temp.next.next. If I just say temp.next.next.data, this will be printing 2. That means I am referring to this node. Okay. So once this is done, simply my connection will be made and the fourth node will be deleted. Again, if I have to release the memory, a few things that I can do here is, first of all, before making this connection, before establishing this connection, I can say current equals temp.next. That means my current will be attached here. My current will be attached here, right? And after attaching my current, I can make this connection, right? Now, I do not have this connection. I cannot use this. I cannot say, now when I say temp.next, I do not mean 10. After this, when I say temp.next, I'm directly referring to 2. Now I can simply release this memory, and I can do that by just doing current, and just for making it proper, I can say current.next equals none. So I'll break this connection as well. And then I have an individual node. I can simply say delete current. Simple. As simple as that. This condition, that means deleting nth node anywhere in the linked list, like anywhere in middle of the linked list, is done. Okay, let's see the code for it. In the code, I have not managed the memory because Python does it itself. I do not need to, and I only have specified one separate case, that is deleting the first node. And the other two cases, that means deleting the last node and any node in the between, will be taken care of this by this else code, right? What am I doing here? First of all, whenever this function is called, position is taken as an argument. We just need the user to tell us what node, at which position the node we have to delete. Once that is done, firstly I have to check that at least my linked list is existing, because if the linked list is not existing, if my head is only none, what will I delete? I'm simply putting up this that check here. So if the linked list is not made, I can simply say the list is empty and deletion is not possible, and I'll return from the function. If not, I'll check. If the position is 1, if the user is asking us to delete the first node, I'll simply move my head. We have seen that, right? And if that is not the case, what will I do? I will have one reference. I'll attach it to the head. You can see the similar code. I'll move it position -2 times. I'll move it position -2 times so that I have my reference to the node which is just one before the node that I have to delete. That means for deleting the nth node, I have to place my current reference to n-1th node, and that will be done by this line. Current equals current.next, executing it for position -1 time. Every time I do that, I'll check that my current is not becoming none. You already know the reason, because we can go beyond the linked list. And once that is happening, I have to say invalid position to the user, and I'll simply return from that. We cannot, when my linked list is only of 10 nodes, I cannot delete the 15th node. Simple. If that is not the case, once that is done, that means my current is successfully placed on the n-1th node. What will I do? I will check that I at least have my next node. Okay, if that is none, I'll again say invalid position, because that could be a case. Okay, and if that is not the case, that means I just have to make this connection. You already have seen that. Current.next equals current.next.next. Right? I hope you have successfully understood this. A quick recap of what we have done so far. We now know how we can create a list and make add node function to that. We know how we can traverse a linked list successfully and we can display all of its elements. We know that how we can insert a node at any given position in the linked list. We know how we can delete any node from the linked list. So all the basic operations of linked list are covered in this video. And I would give one question which will be done using these basic concepts only to you as a homework. And one more thing that I would want to let you know is, after this video, you are now equipped with all the basic tools and basic functions of a linked list, right? You know how to manipulate a linked list very well. Now you can go on, try different questions. All of those questions would be done using these basic concepts only. So you already have all the necessary skills to master linked list. Take these up, practice these, and once you are master of these, you can tackle any question, because any of the further hard level questions as well is going to be the combination of these basic examples and questions that we have done, plus some logic. That's all. Now the homework problem for you. So the homework problem for you is, remove duplicate from a given sorted linked list. I'll explain the question. I'll also give you the basic hint for this question, but you have to code it yourself. And once the code is done and you have submitted it successfully, you must write me in the comments that yes, it is done, and you must tell me how was the video. Okay, let me explain the question to you. The question is quite simple. It is saying that you have to remove the duplicate ones. There are some duplicate values in the list as visible. We have to remove the duplicacy. And the basic hint that I'm given here is that my linked list is sorted, right? So if this is the linked list that I'm given, I have to make a list which would look like this. Okay, all the duplicates removed. I have to return this list, right? How can I do that? It is quite simple. Again, basic concept of your traversal and your deletion will play a role here. How? You just have to put some logic here. You will start your traversal from here. Let's say you have marked your temp here. What do you have to do? Every time you encounter that the node that you are standing on, that value, that node's data is actually equals to the next node's data. That means I'll give you the if condition. If my temp.data is equals to my temp.next.data, if that is the case, what will I do? I will simply delete this node. I'll delete this node. Okay, I'll delete temps next. Now you have to figure out what connections you have to make, how you have to delete that. You already are enough aware of it. So I really hope that after watching this video, you are enough equipped with all the knowledge of linked list, which you can use to counter any of the question of the linked list, right? Your basic pedestal is made. Now you have to own it. You have to practice more questions. And if you like the video, then please tell me in the comments. And if you have any doubts regarding that as well, you can put those in the comments as well. And do like this video and subscribe to our Geeks for Geeks channel. Take care. Thank you.